Okay, hi everyone. For those who don't know me, I'm Blair. I work at Cymonz. Been there for about 3 years now, and been working in Rails for a bit over 10 years at this point. So talking about how to migrate from Oracle to Postgres. So a little bit about the company. So Cymonz is a foreign exchange company and remittance. Initially started in India back in 2011 on Rails 3.0, for any of you who remember that one. But in around 2020, we came back to New Zealand with a little team in Wellington. Now we also have teams over in the UK as well. We're a big Rails monolith, quite big. And we have 4 instances across the different AWS regions. Each instance has many tenants associated with it. And through there, we have about 6 terabytes of data used across all our different databases. So a little bit of work to migrate there. For wording instance, when DB is kind of interchangeable, I may use schema, which means a tenant or a client. They each have their own schema there. So why might you try to escape from Oracle? First one is cost. They are notoriously expensive, and Postgres is notoriously free. For local performance, back in 2024 when we started this, the only option was Dockerized x86 on ARM Macs, because we went with M1. And the performance in that, while impressive, was also impressively terrible. You would have queries for a single get, which would be in the 10 milliseconds to just select a user from a table. Also, Oracle has a 12 gig limit on databases if you're not using a licensed copy. Not a massive issue, but still kind of annoying. Support. So on AWS, your standard edition is 21. That's as high as you can go. ARM support came in 23, so that's what we're all running locally. You can get to 26, but that requires an enterprise license. Annoyingly, Oracle did add a lot of features in 23, so we will occasionally run into issues where you will make a change, send it up, and it blows up on UAT. And we have to use someone's laptop who is still sitting on an older version of Oracle to diagnose that. Features. Interestingly enough, booleans only added in Oracle 26. Things you might take for granted there. Also, stuff like JSON blobs and advisory logs. Kind of nice to have, not necessary, but sort of adds to it. Lots of bugs. We have issues bumping our Rails version, and that was part of one of the main reasons why we aimed to do this. Locks have a weird issue locally and in UAT console or prod console. It will just throw up an error for you saying that limit and lock cannot be used together. Also, Rails likes to put in long index names in migrations. Oracle does not like that, 26 characters max, so work with it. 26, 82, anyway, not very long. And also, interestingly enough, if you look online, you will find people that say they want to migrate from Postgres to Oracle. That is usually because the business unit says you have to be on Oracle for some reason. We don't have that, so we don't do it. Any reasons to stay? As I said, it's gone better. It has booleans. It has ARM support now. And it also works. Surprisingly, nothing's really on fire at the moment. And we've got a lot of work ahead of us to sort of, test and make sure everything does still work for us. Also, interestingly, very lax with views. We are a view-heavy app. And Postgres will complain if you make your views invalid for any reason, changing types on views, changing column ordering, or coercing columns to different types. Oracle just lets that happen, lets the view just fail, and doesn't really complain. So not the best idea, but hey, it is a benefit. So in 2024, we decided to start our migration. The business agreed that yes, this was something worth doing. We got a contractor in to build a migration pipeline for all our data. And we got a mostly functional app deployed, which was pretty exciting. We did, however, stall out. Our application lacks a lot of tests. And being a small team, there's lots of other projects that need to be done, so we got pushed over to those. We did, however, get more drive this year. However, we did actually find that in the past, our app did sort of used to support Postgres and other such databases. There was always a weird method function called Oracle Enhanced that allowed us to, or sort of abstracted different methods in any of the SQL views that you might have. So, left pad, Boolean, all that sort of stuff. Handled it for you. So that was very nice, and that was added back in 2011. But in 2016, that commit message removed everything Postgres related. So no idea what it did, why they did it, but it's gone. So back to scratch we go. So what was our plan? How hard could it be? Pretty simple four-step process. Find a way to transfer the data, fix up all the code base. We use active record. How much else could there possibly be? Run a pile of tests. This was probably going to be what we thought would be the hardest bit. We don't have that many automated tests. And then, hey, just migrate things across one tenant at a time. Start with the first feature branch. Cut out in 2024, and we have kept it alive ever since. Initially, it had a lot of teething issues. Views specifically made this absolute hell. And merge conflicts were many and constant. It has surprisingly gotten very low touch now. I can do it in about 30 minutes a week, or less, depending. It's downright pleasant, which is kind of surprising, but not that I would recommend anyone runs a branch for 2+ years. See some of our FNZ friends for that one. So, migrating the data was the easy part to start with, ish. Most of Oracle data types are compatible, not all. Initially, we had a quick look at doing stuff locally, different tools. Navicat was one that does stuff or did okay locally, but not that fast. We ended up sending that off to contractors, and they came up with AWS DMS, which is a nice little tool that is, cloud-based and fairly well proven at migrating this stuff. The main problem we came across was virtual columns. We used those in a couple of places, but not anything that was a real issue. Virtual columns are basically 1 + 1 = 2, but in a table. So it's like a mixture of a table and views, which is very bizarre, but anyway. So, how does DMS work? Pretty simple. A lot of stuff you might never see. Just a pile of rules and then some Terraform and a bit of shell from what I could see. You have a set of rules. Say you want to add a column, give it or convert a column type, give it the table name and how you want to change it. It'll do it. You can change entire schemas. So interesting, Oracle runs all capital, all uppercase. Postgres is all lowercase. So, simple enough rule to change that, but something we need to do. And anything that we couldn't or didn't want to convert in DMS, we moved over to migrate in the application to try and make it a little bit simpler. So they got us about 90% of the way there for that sort of migration stuff. The initial migration worked, and but a lot can change in 2 years' time. It got basically completely ignored until it was picked up earlier on this year. We don't use the rolling data update, which may or may not cause us headaches later on. So with a lot of data, you have two options. You can either pull it all across at once and just not write to the database in that time, or you can pull it across piece by piece. We are yet to figure out if that's going to be a problem, but it may be. And we now have a lovely full-time infra dev who actually knows how to use AWS and can make all this sort of happen for us. So makes life a little bit easier there. But that was just one instance. So we have 4 different instances, all created at different times in the company's life. And some of them have more changes than others. Some of those changes have been made manually by someone who decided to just pop a quick fix in through console. Some of them were from migrations that have since been deleted for any number of reasons. We decided to minimize the amount of work in DMS by doing it all in Rails land through migrations, tidy it up, try and get everything to look basically the same from a schema perspective, which, we do at least have Rails schema. We can run that after a fresh set of migrations, and that gives us what we think everything should look like and clear anything else from there. Thankfully, none of those edge cases really mattered, so, effectively sweeping it all under the rug. But that's just for data. What about data that isn't really data? SQL views. We, as I said, rely heavily on them. We have 250 of them. A lot of Oracle-flavored methods in there, which do not play nice with Postgres, or worse. Some of them will still work, but work differently, which is much harder to find the issue of. We have a lot of view dependency, 8 layers of them. So you'll have a view depending on a view depending on a view. At least 160 of those depend on at least one other view. There are 3 views at layer 8 deep. So if you change any of those, you have a lot of other views that need to change as well, because remember, Postgres is less happy about views getting out of sync, even if it's only temporarily. And the killer was there was no easy way to rebuild them. They all live in Rails migrations. So if you want to make a change, you need to go back and find the migration where it was previously changed and create a new migration that has all of the views in there. Which really was an absolute descent into madness. I don't know how Laura managed to do it without going completely insane. Initially, we looked at it. Scenic is the seemingly standard way to handle views in a Rails application. Gives you view definitions stored in a reasonably logical way, but it unfortunately wouldn't work with our database adapter and database layout. So we decided to keep them in migrations, which is really wasn't the best idea. We added a new adapter class so that functions would still work where they were, where we had Oracle versions of them, and we would replace anything that should be a function with a DB adapter, so that it would work between both our main branch and our Postgres branch. This did cause the cascading rebuilds. So if you wanted to make a change to one of our lower down views, you would have to go in and change every view that lived above that view all in one migration, which obviously was completely unreadable. You just kind of had to take it at face value that everything would work. Which obviously was a terrible idea. So this year, when we had had enough of that, we decided to spend a bit of time on it, a little bit of AI, a couple of scripts, and we moved these to view definition files, similar to Scenic, but with our own, extra touch on top to work with our app. At the same time, we decided to squash down all migrations. This had never been done in 16 years or whatever, so everything back to 2011. This gave us a lovely PR of 2,300 files changed and 250,000 lines of code removed. Given that our code base at the time was only about 500,000 lines, that's a pretty impressive change there. Also, this was on the Postgres branch, which had the changes that stored the migrations in the views in the migrations, and that ended up being about 50,000 lines that was added just for that. Yeah. However, not our most impressive one. This afternoon, Laura managed to find one that was a minus 600,000 line change. So yeah, a lot of tidying up. Our code base has definitely gotten a lot smaller in the past 2 years. So we now have smallish migrations in a reasonably easy to maintain format. Basic directory structure, you'd have your views under your database migration folder, and that's got a main definition, so that's your source of truth. You keep versions in there behind in case you need to roll back. In your migration, you just have a, hey, go and grab this view, and you let the thing figure out the name and the pathing. We do have to skip, have this thing to skip if it is a new setup, because otherwise you will have some views created, others not, dependencies, make it all fall over. Yeah, and then ordering. Yeah, as I said, it's 8 layers deep, so you need to know in which order should you create all of the views. If you don't specify one, it goes last. And thankfully, we have gotten a lot better at our view usage, so it is less dependency heavy. And I don't think we've done personally, any views that other views will depend on as part of our new set of views. So, while we're in there, bit of housekeeping. We wanted a fresh schema to work with. Yeah, and since we're there, a couple of quick wins. Bigint. In your migrations, you will see integer. Rails as 5.1 did move to defaulting to Bigint for sequences. But interestingly, integer in Oracle actually converts to number 38, which is, Bigint is 19. So it's actually even bigger than a Bigint. And you would basically never run into a collision or running out of space. Yeah, we had a pile of tables that no longer existed. Code had been cleaned up, but we had not added migrations to remove, the old code. So get rid of all that too. And lastly, retconning floats. Our app, which is a finance app, was originally built using floats. That was decided to be a terrible idea, so we migrated everything to a decimal system. This, however, was done with a rake task, and had to be done on a new DB setup, which meant a new DB setup would take in the area of hour to so plus. Yeah, which that's gone now. It's all just decimals from the start, and no one ever needs to know why floats were around. And surely active record handles the rest, right? Yeah, not quite. Maybe for a more conventional Rails app, but unfortunately not for us. Couple of places where active record did not help. Yeah, we have a lot of raw SQL. Being a very old app, active record was not as fully fleshed out as it is nowadays. Yeah, where queries, yeah, complex joins, ORs, yeah, all those sorts of things. Most of them were fine. Some of them did have SQL functions in them, being concatenate or whatever. Yeah, basically try to remove those entirely or replace them with a DB adapter method. Yeah, the types and nulls. Empty string handling is different in Oracle versus Postgres. Postgres treats empty string as its own thing. Empty string in Oracle is null. So yeah, that's another weird one. Permissions kind of worked a lot easier in Oracle. Yeah, it's We do have a multi-tenant thing. You need different permissions. We also have a sort of admin type schema, so you need to jump between schemas. Oracle never caused us a headache. Postgres kind of does a bit. So needed to work around that. And lastly, views have no keys. So in Oracle, it can infer what a primary key is. So if you have a view that is treated as a table, if you give it an ID, it will magically go, oh yeah, ID, that must be, or at least the Oracle adapter will say, oh, that's an ID, that must be your primary key, off we go. Postgres will complain at you, which you don't find out until you try to order something. So yeah, that requires a little bit more click testing to find. Which comes on to testing. Yeah, we completely lack unit tests, for lack of a better word. We do have front-end testing with Playwright, and that is not feature or tenant complete, but it's pretty good. There's a lot of different configuration that goes on with our app. One little change can throw something down a completely different rabbit hole, and you really need to know which settings are the most important in the app in order to be able to accurately test it. Yeah, the tests are run daily via an automation script and gives us the errors if anything blows up, but it's not quite as easy as developing with them locally. Very interested in your talk later, Toe. Yeah, and actually, sorry, we did have a pile of tests, but they were useless, didn't really have any way to run them. The 600,000 lines were tests that were removed that actually just wouldn't run at all. So you might ask, yeah, why don't we just add them? And yeah, at the time it was a bit too hard. AI is easier, makes it easier, but it's still not perfect. And in 2024, AI was definitely not even good to think about handling that task. Yeah, running tests locally with Oracle was kind of hard. Getting the setup and pulling down, it didn't really work for us. Yeah, again, we've got better setup now thanks to InfraDev. We can pull down Oracle databases and test against those if we need to. And lastly, we were using truncate as the testing methodology in RSpec, which that one was on us. That is very slow. It took about 45 minutes to just run the tests to build 400 factories. Changing that from truncate to rollback drops the time down to about a minute. So yeah, if anyone's got really slow tests, that could be something to look at, but it would be very, very slow. So what do we do for testing? Yeah, lots of manual work and a lot of just random clicking around the place, combined with some expert knowledge from our support team, who has been around a long time. Yeah, first off was get one tenant migrated across. That was our main testing one, obviously not locally, up in UAT. Click through every page, see what breaks, see what doesn't. Yeah, and if there's anything blatantly obvious that is missing, compare once that's all done, you need to compare pages. There will be subtle issues that exist. Typical one was that persons' names would be incorrect. It wouldn't have joined the last names together or first and last name together through the Oracle views. It was mostly the view functions. And at the time, this did involve the full view pulling down and rebuilding together, which made this whole testing thing a lot slower. But hey, you find the issue, you fix it, look for any other issues that look similar. It's easy enough to find if there's a broken function, that function exists in another view, fix it at the same time. And slight benefit of having nested views is a lot of the time the problem was only in one view, just 7 layers deep. Yeah, which did work, and all of that worked initially, but eventually we did need our expert knowledge, which their time was very limited, so not much we could do there. Yeah, on to migrating UAT, getting all the tenants across. We're not running it full time because we can't really block releases. Postgres is a separate branch. We still want to be testing against Oracle for basically every purpose. And webhooks are a bit of a pain point against that. We don't want to change the webhooks across to be pointing against a Postgres instance is a lot of work. It's somewhat more work to change the instance to point against the Postgres instance instead, and just swap it back later. A lot of silence differences, or just data looking a bit off, but it's just testing. But we would like to try to run the DMS stuff more regularly. Ideally, having to blow the data away is actually a good feature. There we go. It's good to know that the DMS does all still work, and that we're not going to run into any issues when we're trying to do a big migration of any tenants there. Schemas are less of an issue. We have our main set of or our main schema that basically everything follows now. And we are pretty standard with the way we change things. We're not expecting to run into any differences between instances or tenants. So getting it to production. I thought we would be there already. We are not. When Jordan asked me to do this talk much earlier in the year, I was very optimistic, and that apparently was wrong. But we still have a basic plan on how we're going to tackle it. Blessing being a tenant-based system is we can move one tenant at a time. We can start off with smaller clients who have less space and will, probably yell at us less if something goes wrong. We kind of have a way back. It'll be a change window. We can click through the production app once it's been switched over, but we kind of just have to fail forward at that once we turn them on for Postgres full time. There isn't really a way to have both running in sync. Gonna have to do some wrangling of tenants. As we said, we have some that are small and easy, some that are bigger and more particular at times when we can shut their app down and have it for a full weekend. And we're probably going to have to give them a lot of advance warning on that one. So, what's left? As I said, not much left really. Not everyone has been migrated away from or migrated across on UAT, so there's still a little bit more config testing to be doing there. We do need the full confidence that we can cut over completely to Postgres, and not enough manual testing has been done there that we know everything should work. We do have one client that is fully in Postgres and everything seems to work, but hey, maybe that's just their config. Maybe we haven't run into anything that breaks down. And then obviously turning Oracle off. It only starts to actually save us money once we kill that final Oracle instance. So what sort of things do we learn? A tidy schema does make your migrations a lot easier if you're not having to worry about all those little differences you'll find throughout the place. And having it all in one small file that can actually be run in a reasonable amount of time is quite useful too. Making changes easy to backport. initially, part of as I mentioned, the branch for Postgres was a real pain in the butt to work with. But once we sort of got everyone on board on, hey, here's how Postgres works, here's how we need to sort of make changes going forward, yeah, it became not really a problem. 30 minutes or less every Monday, get to merge across, and that's how it's been for basically this entire year. Yeah, a good way is to push it for a customer. We always talked about, this is what we need. There's this and the other reason that we need it, but it's all about us. Once we finally got it for, hey, this customer needs it, it's a lot easier to push it forward and actually spend the time working on it. And lastly, I'd say, yeah, the in-house knowledge is worth it. It's a lot nicer than having someone who's outsourced and a contractor to work with. Having someone in the office with you or just there on Slack that you can message and work through a problem together immediately is quite invaluable. So big thanks to our infra dev there. Yeah, and I think that is me. Any questions?